lithosphere is, and we're going to find in a bit, learn the components of the lithosphere. So I want you to be able to identify what the lithosphere is, identify and explain the different parts of the lithosphere, and then explain the role of plate tectonics. So let's have a look at what we're going to be studying in the next few weeks. Well, when we look at the surface of the Earth, and that's what the lithosphere is, we need to start looking at the forces acting on it. We've used a lot of detective work around, and we've discovered that plate tectonics exist. We've explained how volcanoes, earthquakes have happened, and why some rocks are in places that they shouldn't be. And it's those forces that have put those rocks there that we're going to be looking at. Before we look at the surface of the Earth, we need to understand what's happening below that surface, and we're going to be looking at tectonic activity in this lesson. Tectonic activity can be slow, sudden, but it's acting all the time on that thin, rocky lithosphere layer that we sit on. This is the solid layer around the Earth, and then underneath our feet is the semi-liquid mantle. Since obviously modern science has begun, we've had some very significant changes in our knowledge of the Earth. We can now say what the structure of the Earth is. We can now explain how Earth has changed over time, and we can start to predict what might happen in the future. And this is really important, especially when we start looking at other planets. The structure of the Earth. Let's have a quick look at this. There's three main parts: a thin rocky crust, a soft rocky mantle, and a liquid nickel iron core with a solid center. And what does it look like? It looks something like this. It's a very basic, easy diagram which you've all seen probably in science before. So yeah, that's what Earth looks like beneath our feet. If you want to work out what a better idea is, if you look at an apple, the Earth's crust is very thin. It's almost as thin as the skin on the apple. And despite what humans have done in terms of mining, we've really only scratched the surface. Some of the deepest mines are probably about 2 to 3K. The thinnest part of the lithosphere is 5 kilometers. The deepest is 15. So we really have only scratched the surface of the lithosphere. The Earth's crust, as I've just said, it varies in thickness according to where you are. The crust is basically thinnest under the sea, and hence hotspots. It's only an average, and this diagram shows you, explains why it's not equal. The rocky crust is not as dense as the middle of the Earth, so that's why as we go down towards the centre of the Earth, you get more pressure because it's dense. So that gives you some understanding of what the lithosphere is compared to the centre of the Earth. What's the evidence of this? So, like I said in class the other day, it's not until about the 1960s that we start agreeing that there's this idea of continental drift. As I've said before, some continents easily fit together, like South America and Africa. The evidence started off by looking at fossils, and then people started looking at the rocks, and saw that was not only the shape, but the different rock strata that explained that they were linked, but we didn't understand how they were linked, and that's what plate tectonics is all about. So by using surveys of the ocean floor, people started explaining what plate tectonics was, and basically we got this idea that the Earth's surface is made up of lots of different types of plates that are in slow, constant movement. We'll look at the different movements later. The ocean floors are continuously moving, spreading and sinking at the edges, hence why we get more tectonic activity, earthquakes, volcanoes where at plate boundaries where plates meet. Convection currents, that's how the plates move around. So that's what that's going to be the end of the lesson. We were looking at lithosphere. You needed to identify what the lithosphere was, get an idea of what plate tectonics are and what they do. Again, this is you've probably already covered this in some of your science lessons. So now we're going to start looking in our next video about those movements. Okay, thanks for that.